They will be going over Power BI data modeling, basics to data modeling, and an introduction to Power Query or mQuery language. This presentation will be a mix of lecture series through PowerPoint as well as a follow-along lab that you can find the resources in the SharePoint folder I sent out in an email. By the end of this course, you'll be able to use Power BI Desktop to import and shape data from a variety of different sources. Specifically, you'll be able to understand the Power BI Desktop data model, its components, and most effective schemas, gain an understanding of the Power Query M language, and import data from a variety of sources, including XLS and CSV files. We'll also be able to create queries using the toolbar navigation and the advanced editor. We'll understand parameters and functions, and we'll organize queries using folders. So this is the original kind of schedule that they suggest for the class. We will not be going over like optimization techniques and DAX. We'll really limit this to the mQuery and data modeling. First part is data modeling, basics of data modeling. The objectives of this is to understand the basic architecture of Power BI Desktop, as well as understand Power BI modeling terminology. Generally, the data flow works that you have your data sources. These will then flow into the query editor. And from there, you can do some transformations. After you close and apply, this will report it into, this will import it into the report view. And from report view, you can then throw it into visuals and you'll have the report option, the data option, and then the relationships and modeling view. Data model improves understandability of the data. It increases performance of dependent processes and systems, and it increases resilience to change. In a good data model, the model can assume that column types are of homogeneous data type. And this is different from Excel, where any given cell in a spreadsheet can contain different information. So there are two main components of a data model. Generally, you have your fact tables and you have your dimensions. Fact tables contain measures or items to be aggregated. Examples might include transactions, sales revenue, unit costs. Measures are generally sliceable. Example, you can slice it by month or by customer. So I can see sales by month, sales by customer, units by month, unit by customer, etc. The other element is dimensions, which are what that slicing is. So by customer, geo, or month. A dimension table contains descriptive attributes that define how a fact should roll up. You will generally connect your fact tables to dimensions. So connections between two tables are known as relationships, and they use columns from each of the tables to link them. There are three kinds of relationships: one-to-many, one-to-one, and many-to-many. And this refers to the uniqueness or how many times a value is repeated. So in your sales table, you might have a product ID that links to your product ID in your product dimension. So you might sell one product to multiple different customers, so you'll have multiple rows of the same product with different sales amounts pointing to different customers. But in your product dimension, you'll only have one product ID. So you might have this many, which is this star to that one. So every time you see that product, you'll know that that product has a certain name. It's part of a certain category in a certain segment. It's related to a certain manufacturer and has a certain unit cost. Data models bring facts and dimensions together, and there's generally three kinds of data models. This is not an exhaustive list, but these are generally the ones you'll see in Power BI and the ones you'll see in BI in general. But you have a flat or denormalized model, a star schema model, and a Snowflake schema. So a flat or denormalized schema is generally what you would see if you were to build a Power BI file or a data model off of a single Excel table. All attributes for the model exist in a single table. They're highly inefficient. The model has extra copies of data, and they generally lead to slow performance. And the size of a flat table can blow up really quickly as data models become complex. The star schema is a more advanced way of modeling your data. Generally, you have your fact table in the middle, and it's surrounded by these dimensions that inform it. And so it looks like a star. A fact table is the many side of the relationship. So you can see the stars are all on the fact table, or the little asterisk for the many. And the dimensions are generally the one side of the relationship. A snowflake schema is similar to a star schema. The center of the snowflake is a star schema, with the fact table in the middle, surrounded by dimensions. But sometimes dimensions snowflake out into other dimensions. An example of this might be your customer dimension, which would snowflake to your geography dimension, so that this geography dimension is really where your customer exists. Um, as Another example might be manufacturer. You could pull out like a manufacturer dimension and have it inform your product dimension, and then you could have another uh, geo dimension out here that informs your manufacturer dimension, so you can know where your products are being manufactured and so forth. So that generally, when you have it spread out like that into multiple dimensions informing dimensions, it's a snowflake model. Another really key concept is granularity and multiple fact tables. So granularity, or grain, measures the level of detail in a table. An example might be one row per order, or per item daily or monthly date grain. In this case, like our sales is the granularity is by product ID, customer ID, and campaign ID, as well as date. So those four combined really determine our granularity for sales. If you have fact tables with very different granularities, it's best practice to split them into multiple fact tables and connect them to shared or conformed dimensions. Um, so as you can see here, we have the sales and the budget. They're two different things that we're talking about. One is actual sales, one is budget, of course, but they might share certain dimensions, such as the cat seg dimension or a date dimension. There are different data types to consider. Amongst the numeric data types, there are whole numbers, decimal numbers, and fixed decimal numbers. There's also Boolean types. Among the date time data types, there's date, which is internally stored as an integer, time, which is internally stored as a fraction between 0 and 1, and date time, which is a combination of the two. And then there's other date types such as text and any. And one of the big things is you should never really use this in a data model, as it makes bad things happen. Um, Essentially, you won't be able to create relationships in certain instances if your data types are wrong or too ambiguous. The most common one I see is trying to connect a date and a date time data type together in a relationship or in a merge or a query. So essentially what will happen is, and this is what this pro tip is about, this data type is different from format. You might format in your report, you might format your date time as a date. And so every time you see it, it's going to show up as just a date without the date time. Um, and then when you try and connect it to an actual just date dimension, some of your records are going to be missing, because the date dimension is really set to 12 a.m. And so it's mismatching on the time underneath it, because again, data type is different from data format. And so you'll miss some of your records in your relationship by doing that. Designing good data models. So generally you want to go for a star schema. It is your go-to structure for most data models. And this is because it saves RAM. Um, so some tips and tricks to save RAM and increase the speed of the model. If a fact table contains an ID field, which is unique for each record, remove it. It also helps to sort columns before bringing them into the Power BI data model, and to change all of the any data types to the appropriate data type. So before we jump into lab one, here's just kind of a general knowledge check. Um, I'll read them out. I'll give you a little some time to think about it, and then I'll tell you guys the answers in a second. So what allows tables in the data model to talk to one another? What type of schema has all attributes for a model in a single table? When would you use multiple fact tables? All right, so what allows tables in a data model to talk to one another is a relationship. Unless you want to answer it, go ahead. The type of schema would be a flat schema, or a denormalized model, contains all the information in a single table. This is definitely what a lot of beginners will use, and it's a good way to just kind of get started really quickly. But generally, you want to normalize your data model. And then when you use multiple fact tables, when you have multiple granularity, you will use multiple fact tables. All right, so let's begin lab 1. Let's shift over to Power BI. In this lab, we're going to import multiple data tables from a single Excel source. The estimated time for this lab is about 15 minutes, but we'll see how fast that actually takes. First, we're going to do get data, and we're going to click Excel. And then we're going to navigate to the folder, and we're going to pull in Van Arsdale Actuals. Go ahead and click Open. And we're going to select all of the following tables: campaign dimension, date dimension, geo dimension, product dimension, and sales. So we're basically taking sales in all of the dimensions except for customer dimension for now. And we're going to click Transform Data. This is going to open up Power Query. And then in the geo dimension, we're just going to change that zip to type text. And if you've been with us before, you'll know that I really stress, change type to type text. You'll know that I really stress that you have to do replace current. If you were to add another change type step after this, it's going to evaluate them iteratively. And so it'll do that change type to number first and then text, and then you'll miss out on the leading zeros. So module 2, getting started with M, Power Query language. So the objective of this module is to understand the basic syntax of the M language, understand functions and keyword structure, understand how to connect data, understand the basic structure of advanced editor, and the agenda is we're going to go over the M language overview. We're going to go over basic data import. We're going to talk about text functions, and we're going to create and apply degenerate dimensions. M has amazing capabilities to transform your data to optimize it for the data model. There are 3 ways to use M or to create M. You can use it in the ribbon, which we've done in the dyad before, just kind of the basic UI click and drag options. The click and adjust method, which is you can create options and then adjust them in the formula bar, and then custom code, which is really taking that advanced editor and just coding as if it was a coding language. As you can see, there's this little simple to advanced. So as you go through Power BI, this is kind of the direction you want to head, at least around Power Query. It's the same thing with DAX generally. You'll start from just kind of using pre-existing options and then move more towards really using custom options to really make your reports pop and give you exactly what your end users are looking for. So some key concept of M is the key to data transformation in Power BI. Many transforms are just a click away on the ribbons. You can turn on the formula bar. So if we go back to our Power Query and you click View really quick, you'll see that the formula bar check mark is here. So if you don't see the formula bar, you can turn it on here. You can view the full syntax of M in the Advanced Editor, and M is column-based. M is also case-sensitive. And another thing I might add is that M is reference-based. In some ways, it is like order dependent, but if you actually look at Advanced Editor, if we go here and we go to Advanced Editor, you can actually change these steps and change the order of these steps, and it would still work. It's really reference-based. So as you can see here, this geo table references source, which is found here. And this table that transform column types references geodim table, which is found here. So insofar as your references are correct, you can actually change the order. It doesn't necessarily matter which steps you call. And you'll see later this is advantageous in terms of writing variables out. Some more key concepts of M. M formulas are the foundation of transformations. Generally, the syntax is object.action. Objects can be tables, lists, record, text, number, date, etc. And actions vary between different objects, but some might be to list, day of week, to number, and from text. Remember, it is case sensitive, and these ones are generally camel case. There's some M helper words. that are similar to functions and similar to other coding languages, such as let in and each, if, then, and else, true, false, error, and or not, try otherwise. Um, Sub key punctuation is that columns are referenced with brackets and lists are referenced with curly brackets. M hashtag keywords are used to create new artifacts and literals. For example, date 2016-0101 is an example of like hashtag date parentheses reference your year column, your month column, your day column. Hashtag date time, hashtag time, etc. Text functions. So the way to read this is this, maybe this is like a table you have, and this is the value for my column. And this would be for each header is an example of a text function you might use, such as text.start, text.end, text.range, etc. And these are kind of the results you might expect depending on the other parameters that you put into your function. So we can start with the best way to understand text functions is that each character in a text has a position or index. And in M is 0 index based. So text.range and text.position of start by counting at 0. So you can see here M, like A would be 0, B, this little example here. This is how it would be. Compared to Excel, which has a very similar function as left, will actually start at 1. It's 1 index based. You'll also notice that Excel is not case sensitive while M is. And so for text.start, you're going to name that column, so that my column here, we reference the column, and then we want to take the text, the start of the text up until index 3. And you'll notice that it's going to go up until index 3, so then we get ABC is returned. Versus in Excel, we still reference 3, but it includes it 3 as opposed to up until. So then that's how we get ABC from there. In M, text.range is going to go, it's going to start at index up into, it's going to start at index 4, and it's going to take 3 different spots. So 2, 3, 4 is going to start here at index 4 and go 4, 5, 6. Versus in Excel, because it's 1 index space, is actually going to start at 5, but still does that 3, 5, the 5, 6, and 7. So then we get 2, 3, 4 from there. And then to kind of find the position of a certain column or a certain character in a column, we might do position of. We do the column that we want to operate on, and then we do in quotes the text or subtext that we're trying to find. So in this case, 5, and it's going to return the position. In this case, the position is 7. Excel, the equivalent function is search, and it's going to return 8. So again, here's kind of the various M text functions you could use. And here's the equivalent in Excel. But they would both have the same output, granted that these two equations are equivalent. If then else, so if you're used to other coding languages, you're probably used to if statements. You'll notice that the if then else syntax doesn't require parentheses. It's just, it goes until it finds the next component. So there's various ways that you can use the if then else. There's the simple method, just a one if statement, chained, where for every else you begin another if statement. There's nested, so in the then statements you might have a decision tree and have an if then statement within the then statement. And last, you could do multiple conditions using things such as or and or other Boolean functions to really combine and create complex conditions. Keep in mind one easy way is that if multiple ifs are used, just ensure that you have the same number of if, then, and else's. So whether you use a conditional column or a custom column, the results will be the same. When you use a conditional column via the UI, it's going to output in the formula bar, or in the formula bar and in the advanced editor, it's going to output a little bit longer table that add column, and then you'll see the previous step that it references, the table that it's gonna, or the name of the column that gets created, and then each if, and then it'll begin the actual function itself, the if statement there. Versus when you do a custom column, that kind of prefix gets excluded, and we're really only going after the if statement. However, when you click OK, both of these will result in the same advanced editor M query. So it doesn't really matter how you do it with the UI or with the custom column, they'll end up the same. So yeah, any questions? We're gonna begin lab 2 then. In lab 2, we're going to be creating a cat seg dimension. We're going to create a dimension using the category and segment attributes from the product dimension. So from the view, first, we want to make sure that parameter always allow is clicked. And then we're going to duplicate the product dimension query. So go to the product dimension query. We're going to right click it and we're going to click duplicate. From there, we're going to highlight category and segment. And we're going to right click and we're going to do remove other columns. Then we're going to highlight these two columns again, and we're going to click remove duplicates. So you notice that, rural is still duplicated multiple times, productivity still has multiple duplicates, but what got deleted is the unique combination of the two because we highlighted them both. So now that we have a unique combination of category and segment, we're going to create an ID for that unique combination. So we're going to go to add column, and we're going to do index column, and we're going to do starting from 1. Then let's reorder the columns, and we can do that by just clicking and dragging. And now I want to rename this cat seg ID. Then let's rename the query from product dimension parentheses 2 to cat seg dimension, or dim. And similarly, we're going to update the product dimension so it has the same cat segment. So from the home query, or select the product dimension query first, and then from the home, we're going to click merge queries. Merges are similar to joins, or they basically are the same thing. We're going to merge queries, and then in the second table, we want to merge our new cat seg dimension. And now what's cool is most people will join on one column, but you can also join on multiple columns. And because we made it duplicates, we know that they're the same. So if you hold Control as you click through, so I click category, I hold Control, and I click segment, and then I do the same for cat seg dimension. You see 212 of 212 from the first table match. We're going to leave this as left outer. We're going to click OK. And we will now have a new table reference in our product dimension. From here, we're going to expand this by clicking on the little arrows on the top right. And we're only going to bring in cat seg ID because we already have category and segment. And we're going to uncheck use original column name as prefix. I'm going to click OK. And from here, we're going to eliminate category, segment, manufacturer ID, and manufacturer. Notice that all of the manufacturers are us because it's internal data. We're Van Arsdal. So we don't really need it. It's kind of obvious that it's us. So we're going to right click and do remove columns. And then we're going to reorder the columns product ID, cat seg ID, product, unit price, and then unit cost. Next, we're going to create a customer dimension. So we're going to go to home, new sources, or you can do recent sources, and we're going to do that Van Arsdale actuals. And we're going to bring in that customer dimension. Go ahead and click OK. Again, before we're going to change that zip code to type text. So right click, change type, text, replace current. And now we're going to use some of those functions that we reviewed, those text functions. So first, we're going to do split email, and we're going to split this email up by the colon. So we're going to right click. We're going to do split column by delimiter. Let's do custom. We can drop a colon. And we'll leave it as each occurrence. There should only be one. And this is going to split that email from the names. Now we kind of want to split up the names, and let's get it so that the first name comes before the last name. And we're going to create a first last name column. But in order to do this, we're going to use some Power Query that we reviewed earlier in the lab. So first, we're going to click Add Column, then Custom Column. We're going to call this Separator. And the goal of this is to find the position of the separator. And in this case, it's the comma between the last name and the first name. So the formula is going to be text dot position of, remember it's camel case. And then we're going to reference email name 2, which is the column with all the last comma first names. And then we want to find the position of the comma. Once you're done finding that position, we're going to click OK. And we're going to use the position of the comma to split the last name and the first name. So let's add columns first, last, and full name. So let's start with last name. Again, we're going to add column, custom column. We're going to do last name. The formula is going to be text dot start. And we're going to take that email name 2. Then we're going to, the position that we want to split it is actually that separator position that we created earlier. We're going to go ahead and click OK. And you'll see now we've pulled the last name from each row. Similarly, add column, custom column. We're going to do first name now. And we're going to do text dot range this time. We're going to reference that email name 2, again, that column. We're going to do separator. But this time, since it's a numeric value, we're going to add 2 because there's the comma and there's the space. And so we really want to reference 2 spots over from that. Press OK. And you see now we have the first name. The last is going to be pretty easy. We're going to do full name. And it's just first name. We can combine text with the and. And then we're going to do a space with quotation marks. Another and then last name. Go ahead and click OK. And I think I might have put too many spaces in there or something. Then you'll have the first space last name. From there, we can just remove the separator column. While I said that the order of the queries doesn't really matter, it's reference based, the reference order matters. Since we already used separator in our earlier reference, we don't need it now, and so we can remove it without worrying. Alrighty, then we'll move on to module 3, advanced M transformations. So the objective of this is to understand M transformations, understand merge and other combining queries, understand how to use multiple queries in an advanced transformation, and use data profiling. So we're going to use Power BI M key transformations. We're going to use uh, Power BI M merge types, and we're going to create a budget fact using a multi-query approach. So key transformations that you will use. Yes, you can use regular expressions. For those of you who don't know, regular expressions are text modifiers to find certain kinds of text, such as, hey, I want to find all numbers in this string of text. Hey, I want to find all letters in this string of text. Or hey, I want to find the first letter after this letter or this phrase. So regular expressions do work in M. So key transformations that we'll be covering are transpose, which is going to convert rows to columns and columns to rows. One issue of this is column headers are lost, so you want to make sure to not promote your headers if you want them as part of your transformation. To transpose column headers, you're going to demote them to the data prior to the transpose. Another key transformation is pivot column. So table.pivot is going to take your previous and then list distinct the previous and then the column that you want as your headers. And then the value in colors column are going to be converted to headers. And the values in the values column will be filled in where applicable. Unpivot columns is the opposite of this. When you have columns with various values underneath, and you really want them into two columns that attribute name, in this case the color, and the value per that color. There's various join kinds or merge types, as I mentioned before. If you're used to SQL, you'll recognize full outer, left anti, inner, right outer, and right anti. These have all the same behavior as SQL joins. So if you have one of the issues you'll have is if you're not completely used to joins or merges, one of the errors people make a lot is if you have multiple rows from one table that match one row from the other table and you do a merge, it's going to expand to the Cartesian product of how many rows match. So let's say you were to merge your sales on a product ID and that product ID shows up multiple times in your product dimension. Well, that merge or that join is going to match your sales product, your sales transaction to multiple lines in the product dimension, and you're going to get duplicate lines of your transaction, and you'll end up doubling your sales. So something to look out for, definitely something to be comfortable with and understand the implications of, but incredibly powerful for transforming your data. Different ways of combining queries. There's the merge, which we just went over, which are different joins. There's append, which is to stack them on top of each other. We did this in the dyad where we appended the US sales data to the international sales data. This is when if they have the same columns, you can stack them by column. Duplicate, as we just did earlier in this lab, where we simply duplicated a query and repeated the steps. And then there's reference, which takes the output of one query, so it takes that last step of a query and uses it as an input for another query. Now, one of the implications of this is if you change the initial query and it changes the output of that query, the input for the second query will also change. Fuzzy merge is a type of join. that allows you to apply fuzzy matching algorithms when combining columns to try and find matches across tables being merged. Um, you might not have exact matches. There might be a spelling error or something. Fuzzy merge, allowing fuzzy merge, will hopefully take care of this. So this is particularly useful when you have millions of rows and you do a merge, and you don't want to go through each row to make sure that it's spelled correctly or whatnot. Data profiling allows you to easily and quickly understand data distribution. You can see column statistics, the number of errors, empty, valid, duplicated, and unique values. Values are distribution measures such as min, max, average, median, etc. You can also see column distribution, larger size versions of the inline value distribution histograms. Um, they also include the ability to keep or remove values, which will generate the corresponding filter row step in your query equals or does not equal filter. Stick around if you have any questions. I'll answer them while we wait. We'll rejoin in about 5 minutes. So right now we're going to create a budget fact table. So what we're going to do is we're going to import, we're going to go to home, new source, text CSV, and we're going to import Van Arsdale budget.csv. We're going to rename the query from Van Arsdale budget to budget fact data, budget fact underscore data. We're going to remove the top 3 rows with the remove function. And then let's duplicate that query. We're going to right click, click duplicate. We're going to call that budget fact. In this case, instead of we're on top of the removed top 3 rows, now we're just going to keep the top 3 rows after we've done the removed top 3 rows. So let's kind of toggle between them. Here we have that forecast 2016 in December. And here we have, here's with the data. I added a uppercase U. Let's fix that. From here, from our budget fact table, the one with just the 3 rows, we're going to click transform and transpose. So remember, that's the columns to rows, rows to columns. And we're going to add a custom column. And we're going to call it budget month. And we're going to do date dot from parentheses, column 3 and column 2. So this is going to append column 3 to column 2. So this should really read December 2016 with no space. And it's going to get a date from there. Forgot how to fix that one. And then here, so I edited my function. What I did is I added a otherwise null after the parentheses. It didn't work, so I added a try in between the each and the date dot from. The each is kind of the start of the function. It tells Power Query where to start the actual function. So this is the function here. And so I surrounded my function with some helper functions. So I did try and then otherwise. And so that if I took those out, for example, let's leave it as it was defaulted, you'll see I get an error here. So in order to handle the error, I'm doing a try. So if it's possible to create a date from these two columns, it will. Otherwise, null. We're going to add another column after that. And we're going to add a custom column. We're going to call this fully combined header. And the formula is going to be, it's a little lengthy, but if text.length, parenthesis, bracket, or in this case, we can just double click column 3. It'll do the brackets for us, is greater than 3. And I actually want to do text.length end parenthesis here. So if text.length, parenthesis, column 3, end parenthesis, is greater than 3, then column 3. Else, column 1. And so we're in addition to that little statement we made, we want to add date to text, parenthesis, budget month, comma, and then we're going to do capital M / capital D / YYY. And then we're going to end our parenthesis. And so it should, you have, if it's greater than 3 letters, in this case, it's going to take this column 1. It's going to then add the little squiggly. And then we're also going to add the date here. But you'll notice that we got 12/D/YYY. And that's because it's case sensitive. And so we're going to modify our formula and do capital with 2 lowercase d's and 2 lowercase y's. Now we're going to remove all of the columns except for that fully combined header because all of this information now is contained here. And what we're going to do is we're going to go back and we're going to transform and transpose it. So now we have our header column that we want to use. From here, we're going to go to Home. We're going to click Append Queries. And we're going to append the original table, budget fact data. We're then going to use that first row that we had as the header. And then we're going to remove the next 3 rows because they're contained in our header. Next, let's highlight category and segment. And then we're going to click Transform. And we're going to click Unpivot Other Columns. I think that went off kind of wrong. I'm going to highlight these 2. And then we're going to click Unpivot, click the little arrow and do Unpivot Other Columns. So we should have 4 columns at the end of this. Then we're going to go to our attribute. We're going to click Home. We're going to do Split Column by Delimiter. And we're going to change that custom to that squiggly we used. And go ahead and click OK. And that's going to split that forecast attribute from the date. Let's rename this to scenario. Let's call this date. And let's call this budget amount. Let's change the data types of the budget amount to fixed decimal. And let's change the date to type date. And then go to home. We're going to go to merge queries. And we're going to go to the cat seg dimension that we created earlier. And then again, we're going to do 1 and then 2, hold control, category and segment, hold control, left outer, and we're going to click OK. We're going to expand that new column like before, and we only want that cat seg ID, and we're going to get rid of the use original column name as prefix. And now we got that index again. Since we have this new column referencing it, we can get rid of the cat seg dimension columns, so remove these columns. And let's reorder this now, cat seg ID, scenario, date, and then budget amount. Now, since we have a duplicate and we appended this, we can disable the loading of this, right-click budget fact data, and click enable load so that it's now italicized. So this will not load in our Power Query. This kind of review, we went from having a table that looks like this. I think this is kind of a normal way that a lot of finance organizations will kind of spread out their forecasts and their budgets, is kind of this widthwise. So this is a very common operation that I see at businesses a lot. And we did a transformation to basically turn that around and use what was in there to provide our headers, as well as to pivot the data in a way that Power BI can understand. Alrighty, and that's it for Lab 3. Next, we'll be going on to Lab 4. So in Module 4, we'll be covering variables, parameters, and functions. So the objectives are to understand what variables and parameters are, to understand custom functions, understand the benefits to parameterizing your queries, understand what enter data is and how it can be used, understand how to organize your queries using folder groups. And our agenda is Power BI M variables and parameters, then enter data, then leverage variables and parameters, and then to create a changelog. So variables and parameters. And variables are queries with a constant value, table, or list result. We can create a new blank query. Query name is the variable name to use in other queries. And then you can type the variable value in the formula bar. The advanced editor would look similar to let source equals, my variable value, and in source is going to reference that. And so that would be your whole query. And parameters. Parameters take variables to the next level. Parameters can be any valid data type. The most common are hard-keyed single switchable values. For example, the actuals file might have the value van Arsdale underscore actuals.xlsx. The values list for a parameter can also come from a query that is formatted as a list. So maybe we have a list in our query that goes over the different files we want to load, and then we can use parameters to toggle between the different files. Parameter usage, we can be creative. For example, we can have a parameter, we can have an if and then parameter to go between SQL Server for a database name, or for a server, such as maybe we want a single Power BI file to be able to switch between a development, a test, and a production environment. We can use parameters to switch between them without having to recreate our Power BI file. We can just do this simply with a parameter. We can do where clauses in SQL queries. So maybe we create a single Power BI file where we only want it to load the data from a particular organization or from all of the organization. We can use where clauses and a parameter to switch between them, so we can have one report that can pull data for various organizations. SharePoint Teams site name. So maybe we have multiple SharePoint sites similar to the SQL Server. We can switch between various SharePoints and file paths and files names to have a single place where you need to make a change. So that's kind of what we'll be doing today is with the file path and file names, is to create a parameter to switch between them. Custom functions. Custom functions help you reuse code. Like I showed during the break earlier, you can create a function using blank query, and you can create functions using baseline queries as well. So when you create function here, enter data, users can enter data. Users can enter data to add a table on the fly, and they make for great mapping tables. For example, I often will do switch statements in DAX, and I want to switch between, forecast, budget, and actuals, or maybe I want to switch between, what do I like to switch between? Like sum and average. So I want my users to be able to toggle between them. I'll use enter data to create a table on the fly to allow users because then you can use this data in a slicer, and then the user can select what they want from there. So let's dive into Module 4 lab, creating parameters and paths. Let's navigate to Power BI again. So first, we're going to go to Home. Then we're going to go to Manage Parameters here. And we're going to click Manage Parameters. We're going to create a new parameter. We're going to call this parameter path. We're going to we don't need a description, but we're going to do type text so that all the values that go into this have to be of type text. And then for current value, we're going to do, we actually want to reference our folder. So we're going to go find our shaping folder here. I'm going to copy the path, clicking up here. I'm going to put this in, and then slash, and then I'm going to do, with a slash at the end of it there. Go ahead and click OK. Then I'm going to, again, create a new parameter. Manage parameters, new parameter. I'm going to call this one actuals file. Again, type text. And the current value is going to be van arsdal underscore actuals dot xlsx. Go ahead and click OK. And then we're going to do one more. We're going to do, again, manage parameters, create a new parameter. This one we're going to call budget underscore file, type text. And the current value is going to be van arsdal underscore budget dot csv. Go ahead and click OK. And those file names should match the different text files, or the CSV document. We have that van arsdal actuals.xlsx and the van arsdal budget.csv. So they need to match what you have in the folder. From there, we're going to create a new blank query. We're going to go home, new source, blank query. And we're going to call this query actuals path underscore path. And we're going to copy in, we're going to click advanced editor. And we're going to navigate to our folder. And we're going to go find the actual paths text document. And we're going to copy in the information or the query in there. So I'm going to take a second to kind of go through this query. every query starts with let, and then in references which, it's kind of your final step, it's your return. It's going to say which step you want to show. So let file path equal path. This is going to be our path variable. So the file path is going to equal the path variable. The file name is going to equal the actual file variable. Path slash is an if statement. We worked on that earlier. So if the text starts with, if the file path starts with HTTP, then we're going to do a forward slash. Else we're going to do a backslash. This is very common in coding for Windows. Generally, Windows is really the one that uses backslash, and everything else uses forward slash. Full path is going to be that file path from the variable, and which is going to concatenate. If the text ends with the file path, then we want the path slash. Else, we're going to not add anything. Otherwise, we need to add a path slash. And then we're going to do the file name. And then we do source. If the text starts with HTTP, then we want to use web.contents to call the full path. If it doesn't, we're going to use a local file.contents and then call the full path. Hope that makes sense. Once you're done, we're going to click done. You'll notice that the various steps that we created are now shown in the applied steps. And you'll notice that it actually already fills out some of the information simply because we already instantiated the path variable and the actuals file and the budget file. Similarly, we're going to do the same thing for budget. We're going to go to blank query. And we're going to copy in the text from the budget path. The advanced editor. Oops, wrong click. Advanced editor. And it's very similar overall. So I won't go through it again. And we're going to call this budget path. So that's how you use parameters. Next, what we're going to do is we're going to use a custom function to take those. So as you can see, the budget path has a lot of it's grabbing the budget path file. It's how it originally was, and we don't have any of those transformations on it. So we're going to use what we already did as a query, transform that into a custom function, and then apply that custom function to this budget file that can be referenced dynamically through a parameter. So we're going to create a new query. And let's call this query FN for function, day since year start. And in the advanced editor, we're going to copy in the text from number_days.txt. And click done. And you'll notice that it looks different. It didn't show any data, and that's because the way that what we copied in is written is a little bit different. If we go to the advanced editor to take a look at it again, we have this source equals transaction date as date, and then then it goes to another let function. So that's going to set up your functions kind of syntax. And Power BI is going to recognize that that's a function. And we'll have the fx over here as opposed to the table icon. So then let's create a new parameter. So home, manage parameters, new parameter. We're going to call this transaction date. We're going to change this to type date. And then our current value is going to be 1/1/2011. And we're going to click OK. Then we're going to go to our sales query. We're going to add a column. We're going to do invoke custom function. The new column name is going to be days from year start. And then the function query, we can just do that function that we had. And then instead of using that 1/1/2011, we're going to set this to we're going to have it reference a column. In this case, we want it to reference the date column. So if we look at the function, what it's doing is it's taking the date and then it's comparing it to the year start of that date, and it's doing the date difference between them. So when we go to the actual sales, we can see that this date is 268 days from the start of the year. And that's it for lab 4. Any questions? It's that is all I was planning on going over today. I was going to skip the DAX section as well as the performance analysis section. You can find those in the lab notes and in the lab manual. These are all part of the SharePoint link that I sent out earlier. What I do want to go over is kind of how to change a function that we used earlier to work on a file that maybe we created earlier, such as this budget path file. So what you can do is you can take a query such as budget fact, and you can right click it and you can do create function. And it says the budget fact query does not reference any parameters. Are you sure you want to create a function without parameters? And you can click create. It's going to ask for a function name. I might call this budget transform. And you can see now I have that budget fact table that we had before, and then it transforms it. And it's now a function type with that similar look. And it's going to ask, since there's no parameters here, there are no parameters to invoke. But what you can do is you can take, for example, maybe we want that we understand that all those transformations occur to the source, right? So all we have to do is replace where that source comes in. If we look at this budget path, this is essentially right now that source. So what we can do is we can look into the budget transform function. And if we change source equals that entire step, and we call that budget path file or the budget path query, we hit OK. That budget fact will now be transformed. So I hope that made sense. That's basically the basic application of functions is you can use them to reference other queries, turn your queries into functions, and then have them operate in a functional manner. And then you can also plug in parameters. So in this case, maybe I wanted to point to different budget files. Maybe my team put together multiple budgets. Instead of recreating a query for each one, I might have a thing here, a parameter, which is like budget path. And then my budget path could flip between them. Or in the case that I already set up the parameter around budget path here, if I were to put in if I were to switch out this CSV document with a different budget, everything would flow through. So yeah, I hope that made sense.